We discussed all of these things. So how will you revise? First of all, what you will do after each class, 15 minutes after each class. Okay. And the best way to do this is, so you write with the black pen or blue pen, right? All of you, yes or no?
Yes, sir.
Correct? Anna. So how will you revise after like for 15 minutes after each class? So you have written with black and blue whatever headings you write and whatever things you do. So you take a highlighter and then you will highlight the concluding points. Okay, what do I mean by conclusions? Conclusions means देखिए packing efficiency निकाल रहे हैं, so we will solve for packing efficiency. That is not that you have to remember. You have to remember just the packing efficiency is equal to, let's suppose 68%. So you will highlight those parts. Okay, then Z is equal to this much. Then you will write the what do I say? The coordination number is equal to this much. The unit cell is that. So you will take a highlighter and you highlight those concluding points. Okay, so in 15 minutes after each class. So once you have done this, what you can do then, 15 minutes before the next class. So no, it doesn't mean that you have to study for 15 minutes only. You will see that if it is 3 page, 4 page, then you can sit 5 minutes also. Okay, no problem with that. So this can be also 5 minutes. 15 minutes I'm just writing. So 5 minutes before the class, what you will do, you will just read the highlighted concluding parts. Okay, fine.
Yes, sir.
Okay. Then every day you have to do some things. Every day there is one thing which is known as newspaper reading. Hey, newspaper पर पढ़ने लगिएगा please. Okay. So when you read the newspaper now, how do you read the newspaper? You don't read the whole newspaper. Have you ever read the newspaper? First of all, tell me guys. Have you ever read a newspaper?
Yes, sir.
Achha, you have now. So do you read the whole newspaper?
No, sir.
No. So you read the headlines. You read almost all the headlines, right?
Yes.
Then you read the part that interests you. Correct?
Yes, sir.
So here also what you will do, you will read the headings, you will read each and every heading, and then you will read in detail, read all headings first. And in that you will read in detail the points that you think you are not very confident about, or the points that interests you also. Okay, so I will never ask you to hamper or curb your interest. So if you are interested in some topic, ye acha laga tha aapko padhne mein, then you read it in detail. No problem. At this point of time, there is no problem in that. Okay. Once the examination start, once the examination date sheet is out, then you don't have to read in details. You don't have to understand even any concept. You have to write question answers, question answer, question answer, question answer. So after the date sheets are out, our focus will be question and answer. But right now, our focus will be on cultivating the interest in chemistry. Okay. So if you are interested in any of the topics, then you read in detail, and also you read in detail the doubtful ones. Okay, the doubtful ones. Fine. These are the things that you have to do with revision. Please remember that you have to do these things every day. You have to do these things each and every time. There should not be any case in which you are not revising things. Okay, so every day, please. Now, once you took a break, then please don't think that अभी तो बहुत रह गया, पीछे का छूट गया. Please ऐसा मत कीजिएगा. Keep revising each and every point, and that will help you in examination very much. But this is, everything is apart from assignments that you are going to get. Okay, so for you guys, assignments, I have thought about the assignments. What you will get is a combined assignment for Saturday and Sunday. Okay, so you will not get assignments on Sunday. You will not get assignment on Saturday. You will get assignment on Sunday, and then you will have the complete week. But again, this assignment will combine both the classes, Saturday and Sunday. Okay, then you will have a whole week. Then I will discuss the assignment on the next Saturday. Okay, fine.
Yes, sir.
Yes or no? Tell me. Fine, na? Because Saturday and Sunday, I know Saturday after you have school, and then after school you have Sunday class. So time nahi milta hoga aap logo ko. So I will give you a combined assignment for both the classes on Monday, let's say, and then you will have to submit the assignment before Saturday. Okay, please, before Saturday. That means Friday तक तो आप submit कर ही दीजिए. ठीक है? ऐसा नहीं कि क्लास के 5 मिनट पहले submit कर रहे तो मेरे तक आएगा ही नहीं, हम कैसे डिस्कस करेंगे. Okay. Fine. Now moving on to today's class. So ABC cubic close packing, unit cell we have seen, packing we have seen, SSC is the unit cell of CCP. Let me copy these parts and move to. Achha, there is one point that I wanted to write here. Okay. So if you have some space, even one line, then you write one point here that is important. You can see that there are two tetrahedral voids and there is one octahedral void, right? So in both packing, both packing has double tetrahedral voids than octahedral voids. Okay, so the tetrahedral voids are double the number of octahedral voids. So if octahedral void is equal to n, the tetrahedral void will be equal to 2n. Okay, and here n is equal to number of atoms that make packing. So if I am using 100 atoms to make any of these packing, ABAB type or ABBC type, then in this 100 packing, I will have 100 octahedral voids and I will have 200 tetrahedral voids. Okay, 200 tetrahedral voids. So please write this information wherever you can. Both packing has double tetrahedral voids than octahedral voids. And if octahedral void is equal to n, tetrahedral void is equal to 2n, where n is the number of atoms that make the packing. Done? Can I move on?
Yes.
Okay.
Yes, sir.
So yesterday you saw a very beautiful packing, ABC type, face-centered cubic. Let me copy this whole thing and move to today's class. Date लिखना बाकी है. Fine. Now, first of all, let us see what will be the Z for this. Okay, first is calculation of Z. Okay, so whenever we are going to calculate the Z, what we are going to look at? We are going to look at the type of different atom in terms of position. So in this unit cell, you can see that there are two different types of atoms with respect to their position. There are atoms in the corner and there are atoms in the corner and there are atoms in the face center, right?
Yes.
Face center. Okay. So here we have corner. So how many atoms are there in corner? Tell me. How many atoms are there in corner?
8, sir.
8 into what is the contribution of each corner atom?
1 by 8.
आप लोग please everyone answer ना, सबको आंसर पता है तो this will be equal to how much?
1.
Very good. Then we have, what is the other type of atom that we have?
Face center.
Face center atom. And how many face center atoms are there? 6. What is the contribution of each? हिबा निक्का आवाज ही नहीं आता है. 11 तो आपने ऐसे ही पढ़ा बिना कुछ बोले. अच्छा नहीं एनर्जी बचाइए आप, रोजा लग जाएगा. 6 into what is the contribution?
1 by 2.
1 by 2, which will be equal to 3. So Z is equal to how much? 1 plus 3 equal to 4. Correct? This is equal to 4. Now I want to show you guys the coordination number. Okay, second point is coordination number. Coordination number, calculation of Z, then coordination number. So coordination number, it is going to be fun from here. So now in this case, what I want to show you guys, you look at this guy here, this green atom. Okay, this green atom. So this green atom will be which atom? This green atom will be this green atom, correct? In the top ceiling, है ना?
Yes, sir.
So this green atom is this green atom, correct?
Yes, sir.
So now tell me, it is touching how many atoms? How many green atoms it is touching?
4.
4, है ना? And which are these 4 green atoms? It is this green atom, this green atom. It is touching these 2 green atoms, है ना? ये दोनों को टच कर रहा है, correct?
Yes, sir.
है ना? Then it is touching these 2 green atoms, correct? Yes or no?
Yes, sir.
Okay. Now one more thing that I want to see. See, now you look at this unit cell. So this green atom is touching the corner atom. That means if it is touching this corner atom, it will also touch this corner atom because the length is going to be same, right?
Yes.
And if this green atom is touching, this green atom here and this green atom here, right? Yes or no?
Yes, sir.
So if it is going from the ceiling face center to the wall face center, that means it can also touch the face centers of all the walls. है कि नहीं?
Yes, sir.
So now it is touching how many atoms? Tell me.
8 atoms.
8 atoms. Fine, 8 atoms. Now, since it is touching these wall atoms, you can imagine that there will be a unit cell just above this unit cell, right?
Yes, sir.
And they will also have how many walls? 4 walls, right?
Yes.
And in the 4 walls, we will have 4 face center atoms, and this one will be touching, as it is touching the bottom one, as it is touching the face center of bottom atoms, bottom walls, it will be also touching the face center of the top unit cell wall. Yes or no?
Yes, sir.
So in total, how many?
12.
12, right? So in this, you can remember it very nicely. So this 4 atom is touching 4 in its own layer, 4 in the below layer, and 4 in the above layer. Yes or no?
Yes, sir.
Okay. Any doubt till here, guys? Hamza, Heba, Darshan, Krishna, anyone?
No, sir.
No, sir.
No, na? Fine. So we have seen the coordination number. It is equal to Z is equal to, sorry, no, Z Cn. Coordination number is equal to 12. Coordination number, it is equal to 12. Okay. Now, so we have seen coordination number. Let us look at the relation between A and R. Now, whenever you want to find the relation, there is one word that you have to remember, that is touch. Okay. So the atoms which touch each other. So for touched atom, you can see that which are the atoms that touch each other. So you can see that these atoms touch each other. Yes or no? These 3 green atoms, correct?
Yes, sir.
So we will take these 3 green atoms only. Okay. So that means we are going to take these 3 green atoms, and these are present inside in the face of a cube, in the face of a cube. So let me make it first. So we have this ceiling. So here we have black and blue, and then we have 2 greens. So I can make it like this. एक काम करते हैं. Here we will have the black atom. Here we will have the blue atom, and these 2 will be the green atoms, and there will be a green atom in the center also. Okay. Now, obviously, these are going to be. What did I make? Situation will be something like this, right? Yes or no?
Yes, sir.
Correct. And we can say that we are interested in these three atoms. So this is a square, right? The edge length is equal to a, है ना? ये सब तो आप लोग को याद होगा. This is going to be edge length will be equal to a, and that is why this red line, it will be equal to a root 2. Correct? Yes or no?
Yes, sir.
This will be r. This will be r. This is again r, and this is r, right? So you can see a root 2 is equal to 4r. Correct?
Yes, sir.
No difficulty?
No, sir.
Okay. So fourth point will be packing efficiency. In packing efficiency, Z into 4 by 3 pi r cube divided by a cube into 100. Then this will be equal to, how much is the Z? Z कितना आया था आप लोगों का?
4.
4 into pi into r cube divided by, this will be 3 into, and we can write this a is equal to 4 by root 2 r. Okay. Then we can write this is equal to 4 by, just wait a second. Okay. Sorry for that. 4 by root 2 r will be whole cube. है ना? कुछ मिस नहीं किया ना हमने? Into 100. Okay. So you can solve this, right? Those who want to write, they can write also the previous parts. If you want me to scroll up, no, I don't need to scroll up because ये यहाँ तक से ही start हुआ हमारा class आज. Write this down. When you are done, send the answer in chat. What happened, guys? Answer नहीं अच्छा अभी आया आंसर. नहीं हमजा, क्यों गलती कर रहे हैं आप? नहीं, नॉट राइट. कृष्णा का सही है. हमजा, कैलकुलेट अगेन. ऐसे ही कुछ आएगा ना? आई थिंक दिस इज राइट. या 3 into 2 होगा यहाँ पे. दिस इज 5√2/6 into 100. वेटिंग फॉर दर्शन, हमजा एंड हिबा. कैलकुलेट कीजिए, छोटा सा है. 5√2 divided by 6. Now it is somewhat correct, Hamza. Waiting for Hiba and Darshan's answer. Yes, yes, yes. Hiba correct. Darshan, आपका आंसर नहीं आया. Darshan, are you there? कहाँ है आप? नहीं है.
Sir, I sent.
You have sent. किसको भेज दिया आपने? Learnivio को, chemistry को.
Oh, I have sent chemistry. Oh, unsent.
चलिए सही है. So you are all getting. So write the answer, that is 74%. Okay, okay. 74%. Now we know 74% is the packing efficiency. We can also write the packing fraction, which will be equal to 0.74, and the void percentage, which will be equal to 26%. Now, moving on, we will also discuss a new thing here that we haven't discussed much in detail. That is the fifth point, I think, right? Yeah. The voids. Okay, the voids. So in this case, we have octahedral voids and tetrahedral voids both. Will be equal to, octahedral voids will be equal to n, where n is the number of, n is the number of atoms making the pattern. Now, since we are learning about the unit cell, so the number of atoms in the unit cell is equal to how much? 4. So n will be equal to 4. Okay, so n is equal to number of atoms, right? So you're not studying the whole pattern right now. We are studying just the unit cell. So inside the unit cell, there will be 4 octahedral voids and tetrahedral voids. It will be 2n tetrahedral voids is equal to 2n, and this will be equal to 2 into 4, which is equal to 8. So there are 8 tetrahedral voids. Please write this down. Let me know if you are done. Done, guys? Voids, are you done with voids? No, no one is done with voids. Acha, everyone is done with voids. Acha, wait a second. I'm not getting any notification about raising hands. Let me stop share. Okay, can all of you please lower your hand? Thank you. Okay, now can all of you please raise your hand? Chalo. Okay, fine. Now I'm getting the notification. Chalo. Okay, thank you, thank you. Lower your hand, lower your hand. ये सब कुछ अभी चल रहा है. Okay. Now we have discussed everything till now. Now we will discuss the next type of unit cell, that is AB type. Okay, AB type, AB type. So we have discussed ABC, which is cubic close packing. Now we are going to discuss ABC type is discussed. Now we'll discuss AB type. So let me write the topic. Please write the topic with me. AB type. Okay, AB type. Now again, for AB type, I will take a set of atoms that is going to make. So let me show you the atoms that I'm going to take. Okay. Now I will keep a set of atoms on these atoms. Let me make one more layer at least. I am focusing on these black atoms. Okay, and then I will get some of these atoms and no, not like this. Yeah. Then I will change the color to red and I will place them in the voids. So you can see I've placed them in the voids. Okay, I've placed them in the voids. Now what I'm going to do, I'm going to take another set of black atoms and I will place them in the void that is made by the red atoms. यहाँ पे आपको आप लोग को दिख नहीं रहा था. आई एम गोइंग टू कवर दीज वाइट्स. ओके, पता नहीं कहीं भूल गए हो आप लोग. फाइन, आई एम गोइंग टू कवर दीज वाइट्स. ओके, इसमें से एक वाइट नहीं होगा, ये वाला नहीं होगा, नॉट दिस वन, ऑल दी अपवर्ड triangles. Okay, I'm going to fill these whites. So see, I have covered these whites, right? Yes or no? Correct? I've covered those whites. अरे हाँ ना तो बोलिए.
Yes, sir.
क्या हो गया?
Yes, sir.
Okay. Now I'm going to cover these whites. ये white जो red atom से बन रहे हैं, ठीक है? Okay. So let me take. ठीक है? रख दिया हमने. Okay. And let me also increase the. ये यहाँ पे whites आए हैं सारे. ठीक है? दिख रहा होगा आप लोगों को अब, है ना? दिख रहा है?
Yes, sir. Yes, sir.
Okay. Now what I will do, I will remove this whole set. Okay, I will remove this whole set, and I want your focus on the bottom layer and these atoms. ठीक है? No problem. और
Yes, sir.
उसके बाद I want your focus on the next layer, that is the red layer, है ना? Red layer के ये atom, ये 3 atom, क्योंकि देखिए बिल्कुल एकदम बीच में है. इन the black ones ना, in the middle only I have these 3 red atoms. सही है? Okay.
Yes, sir. Yes, sir.
Then I will cover these whites with these black atoms. So ये फिर black atom. So A layer is the black atom, those 6 black atoms. Then we have the 3 red atoms. Okay. And then again we have the 6 black atoms. Fine. Got it? Yes or no? Got
Yes.
the atoms that I have selected for a unit cell?
Yes, sir.
और इसको हम यहाँ पे साइड में रख देते हैं. अब काम करेंगे. काम का है ये. इसको यहाँ रख दिया. अच्छा, वो 3 ऐसे हैं आपके. So take this, make it red, keep them here, and then again I will take these 6 and keep them here. ठीक है? No problem till here, है ना? सबको आ रहा है समझ में?
Yes,
Which
sir.
are the atoms, है ना? Which are the atoms which I'm taking? Okay. Now what I will do, I will take the midpoints of these atoms. I will take the midpoints of these atoms and then trying to draw a unit cell. इसको थोड़ा सा बड़ा कर देते हैं. इसको यहाँ पे पहले. And then we will have the same set here also. नीचे भी same set होगा. बस ये है कि बस नीचे चला जाए. कुछ नहीं है नीचे. It is fine only. Okay. Then we have the 3 red ones. वो हम बाद में बनाएंगे. After I have joined these atoms. Okay. We have a black atom in the center also. A black atom in this center also. We have 3 red atoms like this. Can you draw this? We'll discuss the coordination number first of all, है ना? लिख लीजिए आपको जब तक. तो उससे पहले कोऑर्डिनेशन नंबर से पहले यहाँ पे हम लोग इसको लिख देते हैं. हेक्सागोनल क्लोज पैकिंग है ये. The unit cell is hexagon. So this is also known as hexagonal close packing in 3D. Okay, so this is hexagonal close packing. HCP हो गया ये, और ये 3D में है. So ABAB type और HCP in 3D. ठीक है. So we will refer to this from now on as HCP. And if I say just HCP without any context, then you will assume that it is 3D. And also in questions, if you are said that a crystal lattice is having HCP packing or hexagonal close packing, then you will assume that it is a 3D and not a 2D structure, because in real world everything is 3D. Okay. So, done, guys? Done with the unit cell? नहीं किया तो लिखिए, आराम से लिखिए. Krishna is done. Just waiting for Hiba. Hiba लिखिए.
That, sir.
Okay, fine. Now let us look at the coordination number. Okay. Let us look at the coordination number. Fine. So for coordination number, what I want you to do is to focus on this black atom. Okay. Look at the unit cell, this black atom. Okay. I want you to focus on this black atom. Now you can locate this black atom in this packing also, right? Yes or no?
Yes,
ये वाला है ना? And just tell me, in this one layer, it is touching 6 atoms, right?
yes, sir.
Okay. And you can also see that these 3 red atoms that I have highlighted, they are present just on the top of the black atom, correct?
Yes, sir.
Yes.
So the black atom and the 3 red atoms, they will be making a downward facing tetrahedral void, है ना? Generally, we have seen a tetrahedral void which is like this, and there is an atom above, so we get a tetrahedral void ऐसे. But right now it is 3 atoms are above and 1 atom is below. Here also you are going to get a tetrahedral void. Okay, it is just downward facing tetrahedral void. That means all these red atoms, they are being touched by the black atom also. Correct? Yes or no?
Yes, sir.
And here we have, this is the layer A. This is our layer B. This is our layer A again. Okay, so again our layer A. So you have layer A, then B, then layer A, and after that there will be a layer B. Correct?
Yes,
So
sir.
no, in which we will have these 3 red atoms again. Correct?
Yes, sir.
Then these 3 red atoms which are in the next B layer, they will be also touching the black layer that I have highlighted.
Yes.
So in total, how many? What is the coordination number? 6 in one layer, 3 in the above layer, 3 in the below layer. That is
12.
equal to 12. Coordination number is 12 for hexagonal close packing also. Hexagonal close packing also. Now, next is, let us look at calculation of Z. Now, with respect to position, we have different types of atoms, right? We have atoms in corner. We have atom in the face center. See, ये एक face हो गया ना, center में इसके, है ना? This is the unit cell and this is the face. That means it is one of the outside faces, right? So this is face center. So this will write as face center. And there is 3 atoms are inside. So inside one is very clear. It will be 3, face center and corner. So let us first of all look at corner. Sorry, corner one. So how many corner atoms are there? How many corner atoms are there?
12.
12. And what do you think? What is the contribution of each? एक सेकंड, ये फेस सेंटर में लिख दिया हमने, फेस सेंटर में नहीं होगा, कॉर्नर में होगा. Sorry for that. And what is the contribution? Sorry.
So 1 by 12.
1 by
12.
1 by 12. ऐसे बोल दिया ना आपने, हमजा? ऐसे बोल दिया ना आपने? Okay. Let us see. Okay. Let us see. क्या करते हैं हम? अब यूनिट सेल बनाते हैं थोड़ा सा, ना? Let us make a few unit cell so that you can imagine in a better way. ये पैकिंग को खसका देते हैं इधर. Okay. Now you can see if I extend this line, I will extend this line like this, and ऐसे यूनिट सेल बन जाएगा फिर, है ना? दिख रहा है आप लोगों को?
Yes, sir.
है ना? तो ये देखिए, एक फ्लोर में कितना बन रहा है? 3 बन रहा है, एक कॉर्नर को कॉमन लेके, है ना? If this corner is common, then we are making 3 unit cell in the same layer, correct?
Yes, sir.
Yes.
अब एक इसके ऊपर होगा, एक इसके ऊपर होगा, क्योंकि ऊपर भी तो बनेगा, एक इसके ऊपर होगा, right? In the above layer.
Yes, sir.
Yes, sir.
So total, one corner is shared by 6 rooms, है ना? 3 एक layer
Yes,
में,
sir.
3 ऊपर वाले layer में. So this will be equal to how much? 2, right? Then the face center का तो कोई दिक्कत ही नहीं, face center के ऊपर एक होगा, so this is 2 in the face center into 1 by 2, which will be equal to 1, and then you can write the z is equal to 6. ठीक है? तो क्लास के बाद आप लोग ऐसे हाईलाइट कीजिएगा, कोऑर्डिनेशन नंबर 12, z is equal to 6. Okay, चलिए. Now what is remaining? We have to calculate the relationship between A and R. Now we will have discussion. Why did we calculate the relationship between A and R? बताइए तो. We calculated the relationship between A and R. If you remember the specific problem, it was a mathematical problem of eliminating the 2 variables R and A. In order to calculate the packing efficiency, we had to calculate the relationship between A and R. Do you remember, guys? Yes or no?
Yes, sir.
लेकिन यहाँ पे दिक्कत है. यहाँ पे दिक्कत क्या है? Even if I want to calculate the packing efficiency, ना, I will have to calculate the volume of this hexagonal unit cell, right?
Yes, sir.
Now, do we know what is the volume of hexagonal unit or hexagonal cylinder? I don't know what will you name this unit cell also, right? So we have never learned what is the volume of this kind of shape. That is why you don't have to derive the packing efficiency in this case. Okay, you don't have to derive the packing efficiency in this case, but you have to know a few things. This unit cell, it has some dimensions. In cube we had only 1 dimension, but in this unit cell we have some dimensions, and these dimensions are, first of all, see, you have this 1 dimension. Okay, this is one of the dimensions. Then you have another dimension which is here like this. Okay. Then you have the height. Okay, then you have the height. So let us say that this is A. Okay, this is A, this is B, and this height is C. Okay, any problem here?
No, sir.
No. Now there will be angles also. There are three sides and 3 dimensions. There will be 3 different type of angle also. The angle between A and B, the angle between B and C, and the angle between A and C. पहले हम यहाँ पे लिखते हैं A, B, and C. There will be corresponding angles such as alpha, beta, and gamma. Okay, alpha, beta, and gamma. Please don't write anything. Listen very carefully. See, what is the angle alpha? Alpha is the angle between B and C. Okay, alpha is the angle between B and C. Beta will be the angle between A and C. Gamma will be the angle between A and B. आया समझ में आप लोगों को? Did you get it? Yes or no? Tell me.
Yes.
Yes, sir.
है ना? So we have alpha. This is the angle between B and C. Beta is the angle between A and C, and gamma is the angle between A and B. So as you can see here, if I take the alpha angle that is between B and C, so this angle, so this is one of the wall edges, and then we have the floor. So wall edges and the floor, they will have a 90-degree angle. Similarly, if I calculate the angle between C and A, that will also be 90 degree. But if I calculate the angle between A and B, this will be 120 degree. So this is something that you have to remember. You have to remember in this case, you have to remember alpha, it is equal to beta, which is equal to 90 degree. And here gamma, it is equal to 120 degree. Also, you can see here, now I have made the side length A and B a bit different, just to show that it is a 3D structure. But essentially A and B will be equal, but this will be not equal to C. C will be different, C will be elongated. Okay, A and B will be equal and C will not be equal to A and B. Fine. Any problem till here?
No, sir.
Okay. Now let me just write the packing efficiency. This is also 74%. Okay, don't have to derive anything, just need to write 74%. चलिए यहाँ तक अगर लिख लिया आप लोगों ने तो लिखिए इसको, जो कुछ छुटा हुआ है. Then we will again, अच्छा एक काम करते हैं, let me discuss voids also. कुछ तो लिख लिया होगा वो अपनी. So voids आप लोग लिखिएगा यहाँ पे. Octahedral void, it is equal to n. Tetrahedral void, it is equal to 2n. And you guys will tell me in chat how many tetrahedral voids are there and how many octahedral voids are there. है ना? याद रखिए, n is the number of atoms in the packing, and in this packing we are just taking the unit cell. So n will be the number of atoms in the unit cell, and you know what letter determines and tells you about the number of atoms in unit cell. Okay, chaliye, write this down. Send the answer of octahedral voids and number of tetrahedral voids in chat. Got one answer. Let me see. अरे भाई साहब, Krishna, how many atoms are there in the unit cell?
Sir, I think 17.
Then what is this? Huh, Krishna? What is Z, Krishna?
So, number of atoms, I mean, space occupied by number of atoms in unit cell by.
No, not space occupied by pi. यहाँ पे तो volume आया ही नहीं है. It Z is the number of unit cell. Sorry, number of atoms in the unit cell, right?
Yes, sir.
है ना? So there are two different things. Number of atoms making the unit cell, you are correct. It may be 17. But the number of atoms which are inside the unit cell, that is only 6, na effective number of atoms. Because किसी का आधा portion है, किसी का एक तिहाई है ना, 1/3 of the portion. Some of them are completely inside the unit cell, right?
Yes, sir.
है ना? So number of atoms inside the unit cell is 6.
Okay, sir.
Raise your hand if you have to give JE exam. Raise your hand if you have to give JE exam. No one. Krishna. Okay. Now, Krishna, you lower your hand. Others, you raise your hand if you have to give NEET. Okay, fine. Fine.
Excuse me, sir.
हाँ बोलिए हमजा.
Sir, what did you ask just now?
हाँ हमने पूछा था किसको नीट देना है. आपको नीट देना है, जेई देना है?
Sir, JE.
जेई देना है आपको, है ना? दोनों हैं यहाँ पे तो फिर. चलिए. So I think most of you have done. Octahedral void, it will be equal to 6, and the tetrahedral void will be equal to 12. तो ये भी important है. Okay. So this is also something that you have to highlight. Number of octahedral void, number of tetrahedral void. This is important. That is packing efficiency is 74%. Okay. Now we are done with most of the theory part. That means the important conceptual theory parts. Okay. Then there will be some Ghisa-Pita theory, definition of solid, properties of solid that you have been learning from very lower standards. Then you will learn about a new thing, that is types of solid, molecular solid. Then you have ionic solid, right? Covalent solid. So these type of things you will also learn. Those are new, but again, not very much interested. They are factual information. There is nothing conceptual in that. Okay. So the conceptual part is done till now. Now comes the questions for conceptual part. But before that, what I will do, I will summarize the whole thing. So what we had done till now, we have done 1D packing. First, we started with 1D packing. Also, remember, please, the information that is important before all of this are the phase diagonal is A root 2, the body diagonal, it is A root 3, the phase center, it is contribution is half, edge center's contribution is 1/4, corner is 1/8, right, for cube. So these are the information that you have to always keep in your mind in order to answer fastly. Then we started 1D packing. Now in 1D packing, there is only one question that can come from 1D packing, that is the coordination number of 1D packing, which is equal to 2. Then we went to 2D packing. And in 2D packing, we saw that there can be two cases in 2D packing. So one will be square close packing in 2D, and there is hexagonal close packing in 2D. So the information that is important to run is that the packing efficiency of HCP, it is equal to 78.5%, and for HCP it is equal to how much? 90.6%. After that, we went from SCP to 3D, right? We went from FCP, that is spare close packing, to 3D, and we saw that in 3D also we can have two different cases. We can have two different cases in SCP also. Okay, so we can have, what are the two different cases from SCP? We can have either simple cubic or we can have, let me just elongate this one, body centered cubic. From HCP, we saw that HCP can have two different type of voids, upward facing and downward facing. If I keep the atoms here, I will get on the tetrahedral void that is made by at layer of B, I will get a AB type, which gave me HCP, hexagonal close packing. And if I put on the octahedral void, which is now octahedral void, if I put atoms on the octahedral void, I will get a FCC, that is face centered cubic, right? Face centered cubic. Now for all of these, we will write a few things. We'll write the Z for all of these. Then we will write the coordination number for all of these. We will write the relationship between A and R. We will also write the packing efficiency. And at last, we will write the voids. At last, we will write the voids. Now, you take the help of your notebook. Take the help of your notebook and you will answer me, okay? All of you will answer me. All of you will answer me the answers for these parts. Now, whether this is straight or not. Fine. So tell me guys, what is the Z for simple cubic? What is the Z for simple cubic?
1.
Very good. Coordination number is? नोटबुक देखिए ना आप लोग, क्या हो गया है नोटबुक में तो होगा आप लोग
6.
के। हमजा, दर्शन, हिबा, प्लीज टर्न दी माइक ऑन एंड आंसर। ओके, चलिए माइक ऑन कीजिए एवरीवन। सिंपल क्यूबिक में चले जाइए और वहां से आंसर बताइए, बस वही करना है आप लोगों को, है ना। जस्ट गो टू द सिंपल क्यूबिक पार्ट इन योर नोट्स। यस दर्शन, हमजा, हिबा, कृष्णा, प्लीज टर्न द माइक ऑन।
Sir, actually, I don't have that part because I haven't written
Kyun?
it in. No, I haven't written it in my notebook.
Oh,
Because
what about
it was
Hiba?
from the second lecture, and I have written it somewhere else, like in some rough book, I guess. I will write it. No, like I will write it from the lecture. I will watch.
अच्छा, ओके सही। दर्शन एंड हिबा, दर्शन आपने लिखा है ना?
Yes.
हाँ, तो कीप योर माइक ऑन। हिबा आपने लिखा है? देखा लेक्चर, लिखा आपने? नहीं।
sir.
हाँ ठीक है, चलिए तो कीप योर माइक ऑन एंड टेल मी रिलेशन बिटवीन ए एंड आर।
A is equal to 2R.
हाँ, फिर नहीं बोल रहे हैं दर्शन एंड हिबा, कितनी दफा बोले आप लोग को हम? ओके, पैकिंग एफिशिएंसी।
So A is equal to 2R, right?
हाँ, सॉरी। हाँ, पैकिंग एफिशिएंसी
52.6.
वाइड्स।
47.6.
अरे भाई नहीं, वाइड कौन सा वाइड है?
Cubical word.
Cubical wide.
हाँ, What is the Z for BCC?
2.
Coordination number for BCC?
8.
8.
Relationship between A and R?
A is equal to 4 into R by root 3.
हाँ तो ऐसे लिख देते हैं इसको A root 3 क्योंकि बॉडी डायगोनल में है which will be equal to 4R. सही है? Okay? A root
Yes.
3 is equal to 4R. Packing efficiency?
68.
68%. And you don't have to remember the void. Okay, even though I have written, I think the void, you don't have to remember it. HCP, what is the Z? What is the Z for HCP?
2.
हैं? अरे अभी
नहीं।
पढ़ाया अभी पढ़ाया ना HCP 3D या 3D. This is 3D all. Okay, this is also 3D. This is also 3D. We just learned na HCP ABAB
Yes,
type.
6.
6.
Yes,
Coordination number? Coordination number?
12.
Relationship between A and R? इसमें नहीं याद करना है. Okay. Packing efficiency?
74%.
74.
Okay. Void. Here we have 6 octahedral void. This is important. That is why I am writing how many voids are there. 6 octahedral void and 12 tetrahedral voids. Okay. Now FCC. What is the Z for FCC?
4.
4. Coordination number?
12.
12. Relationship between A and R?
A root 2 is equal to 4R.
Very good. Packing efficiency?
74.
And then the voids. So there will be 4 octahedral voids and 8 tetrahedral voids. Please remember these are the voids inside one unit cell. Please remember that. Okay. We're just talking about the unit cells. So 6 octahedral and 12 tetrahedral. ऐसा नहीं कि कितना भी बड़ा solid हो जाए उसका 6 रहेगा. No, in one unit cell it will be always 6 and 12 tetrahedral voids. Okay. So write this down. Raise your hand when you have done. Then we will do one question that will give you a taste of the question, type of question that we are going to do, and then we will do more questions in the next class. Darshan is done. Waiting for others. So whatever is written here now, this is the only, these are the things that you have to remember. Okay, you cannot afford to forget. Now in HCP and HCP you can see that in दोनों में I have not written a few things. अच्छा यहाँ पे 3D बस ऐड कर दीजिए आप ताकि याद रहे. This is for 3D and this is for 2D. We have not written the void for square close packing, coordination number, and the type of unit cell. ठीक है? But those things are also important. Done. I think everyone is done. Everyone is done. दर्शन हो गया ना आपका?
Yeah, yes.
Write a question. An element has BCC structure. Element has BCC structure with cell edge of with cell edge of 288 picometer. They are asking the atomic radius is how much? Okay, so you have been given some options. So 2 by 4 into 288 picometer, or 4 by root 3 into 288 picometer. C option is 4 by root 2 into 288 picometer. Then you have the option that is root 3 by 4. Oops, 288 होगा यहाँ पे. Send the answer in chat. हाँ, लेकिन उसका कुछ लेना देना नहीं है ना इससे तो. Yes, that is correct, but that doesn't have to do with anything in the question. What is the atomic radius? हमजा हड़बड़ा के आंसर मत दीजिए आप. Think and tell. Calculator. Basically, you use pen and paper. अभी आप pen and paper इस्तेमाल कीजिए. Send the answer भाई. आप लोग ये मत कीजिए प्लीज. You have the relationship between A and R. बस आपको वही फाइंड करना है, कुछ कैलकुलेशन भी नहीं करना है. ठीक है, send the answer. Yes, Darshan. Yes, Krishna. Waiting for Hamza and Hiba.
Sir, I sent it already, right?
No, that is wrong. आपने कैलकुलेट मतलब कॉपी में किया हमजा या मेंटल ही आपने बस उसको कैलकुलेट कर लिया? बताइए तो.
Sir, mentally.
नहीं, कॉपी में कीजिए भाई. नीट 2020 का सवाल है. Question is easy, but you have to at least take some pen and paper. हिबा क्या हुआ आपका? हिबा, will you answer me at least? हाँ, correct. हमजा वही आ रहा, सेम आ रहा आपका?
No, sir, I sent to D.
अच्छा डी, अच्छा अभी आया, सॉरी ठीक है, चलिए, यस करेक्ट, डी इज द राइट आंसर. तो सी द बेसिक अप्रोच, आप लोग को इस तरह का कोई भी सवाल आए सेल एच और एटॉमिक रेडियस का, you have cell H and atomic radius and you have BCC. So you have the relationship A √3 is equal to 4R. ठीक है, उसके बाद क्या करना है? What they have asked, atomic radius is. They have asked what is the atomic radius is. So in this case, R is equal to how much? R it is equal to √3/4 into A. What is the A? 288. यहाँ पे बस 288 लिख दीजिए, तो ये D ऑप्शन आ गया. ठीक है, so start with this. Cell H and atomic radius का relation चाहिए. You have the condition that is BCC, then you write it, then you see what are they asking. They are asking the atomic radius or the cell H. If they are asking the atomic radius, then you will write R is equal to this much. If they are asking the cell H, then you will have written A is equal to this much. Okay, चलिए